Hi, this is Das from Das Edu. Today, I'll discuss about the second law of ECG, which is Wilson's centric dipole model. Okay, so in the previous day of biomedical instrumentation topic, I have discussed the first law, which was first law of ECG, which was Einthoven's law. And over there, we have seen that as per Einthoven, there at the center there was some single dipole which is acting at an angle alpha direction with respect to the horizontal reference direction, and we were also concluded that Einthoven's all the assumptions were wrong, though his law of ECG was one of the basic law of ECG. So right today we will discuss about the second law of ECG, which is Wilson's centric dipole model. And as per the modern experimentations, we have seen that inside our body there is not a single dipole but multiple number of maxima, multiple number of minima is present there. That means multiple concept is there inside our body. But Wilson is also taking this particular concept of centric dipole model, what he has drawn. Let us discuss right here, right now. So let us start. So Wilson's assumption was the human body was a sphere whose sectional view is a circle, okay? And at the center of the sphere, the body, that means the body, there is a single dipole at an angle alpha with respect to the horizontal or reference direction, okay? So this is that particular single dipole acting inside our body, okay, at the center. And this is that particular sphere which Wilson assumed that the human body is some sphere, and we have taken a sectional view of the sphere, which becomes a circle, and this is that particular circle. Okay. So now some simplification. As per Wilson, this is the sectional view of the human body, okay, which is basically a circle. Okay. So our left arm is at 30 degree with reference with respect to the reference direction. Our right hand, our A, is at 150 degree and our left leg is at 90 degree. Okay. So this is as per the assumption of Wilson himself. And also he assumed that the human body as circle as per the cross-sectional view. Okay. Left arm is 30 degree with the reference, as I have mentioned. Right arm is at 150 degree with the reference direction, that means the horizontal direction, and left leg is at 90 degree with the reference or horizontal direction. Okay. So now over here, see, this is that particular dipole which is acting at an angle alpha with respect to this horizontal direction. And as the left arm is at 30 degree, so there is a difference in between the alpha angle which was the particular angle in between the reference direction and the dipole direction. This was the alpha as per Wilson, and the left arm is at 30 degree. So there is a difference is theta. That means theta is equal to 30 minus alpha. Okay. So we here consider that theta is equal to 30 minus alpha, whatever. Okay. Now the derivation becomes nabla square phi is equal to 0, where phi is the potential acting at an angle alpha. This particular dipole Wilson has considered as phi. Okay. Now we solve and find it as phi is equal to b small b over capital R square cos theta into twice small r by capital R plus capital R over small r whole square, where b is some constant and r is the radius of that circle. Which circle? This is the circle. This is the circle which he considered as the human body as some sphere. This is that particular circle whose radius is capital R. Okay, the radius of the circle, where polar coordinates are taken as r and phi. Sorry, r and theta. Okay, so this angle should be theta. So now let us, if we assume that the point where we calculate the potential is on the surface of the sphere, then small r becomes capital R. Okay, so as per our advantage, we will calculate the particular potential on the surface of the sphere so that small r becomes capital R. Now, if we substitute this particular expression with small r with capital R, okay, it will become phi is equal to thrice b over r square into cos theta. Okay, so you can replace the values of r into small r, r equal to capital R equal to small r. This particular expression will become this small expression as 3b over r square into cos theta. Okay, now as per Wilson, 3b over r square becomes another one scale factor, and he assumed that the value of scale factor is equal to 1. Okay, so the value of the potential phi according to Wilson is now become phi is equal to cos theta only. Put the expression number or equation number 1, and this is the starting point of Wilson's equation, where the particular expression becomes theta, phi is equal to cos theta. Okay, so now we will try to evaluate Wilson's equation on Einthoven's electrodes, and we will apply Wilson's equation on Einthoven electrodes. We get phi LA is equal to cos phi means what? Cos theta is what? We have shown over here that theta is equal to 30 minus alpha. Theta is equal to 30 minus alpha. So that particular value I have written here. Theta is equal to 30 minus alpha. 30 minus alpha I have mentioned over here. Okay. So now after simplification, we get cos 30 cos alpha plus sin 30 sin alpha, which becomes, after replacing with its values of cos 30, is root 3 by 2 cos alpha, sin 30 is half sin alpha. So phi LA becomes root 3 by 2 cos alpha plus half of sin alpha. Okay. Next, phi RA. Phi RA will be equal to cos of 150 minus alpha. How it becomes? So I have to go again over here. Okay. So see over here, the angle theta will become 150 minus alpha. Okay. 150 minus alpha. So that I have written over here. Phi RA is equal to cos of 150 minus alpha. Now I'll simplify this particular expression, cos 150 cos alpha plus sin 150 sin alpha, which becomes, after substituting with the values of cos 150 and sin 150 degree, I rewrite the expression as minus of root 3 by 2 cos alpha plus half of sin alpha. Okay. Similarly, if we consider phi LL, that means the potential at the left leg, that would become cos of 90 degree plus alpha. How it becomes? Similarly, we will calculate this value from here. So if it is alpha, the left leg position is at 90 degree. So 90 degree plus alpha. Okay. So I have written phi LL is equal to cos of 90 degree plus alpha, which becomes phi LL is equal to minus sin alpha, as 90 degree plus cos of 90 degree plus alpha becomes minus sin alpha. Okay. So now the second scale factor as assumed by Wilson is V by root 3. Okay. Arbitrarily second assumption as per Wilson, and he multiplied that value of V by root 3 with all three expressions achieved at each of these particular potential derived at left arm, right arm, and left leg. So he has just multiplied v by √3 with each of the expressions. So he got phi LA is equal to v by 2 cos alpha plus v by √3 into half sin alpha. Okay, phi RA will become minus of v by 2 cos alpha plus v by √3 into half sin alpha, and phi LL will become minus v by √3 sin alpha. Okay, so how this particular expressions has been achieved is by multiplying each of this expression by v by √3. Okay, so if you multiply this phi L expression with v by √3, what will it will be become v by 2 cos alpha plus v by 2 √3 sin alpha. Okay, v by 2 √3 sin alpha, exactly the value has been got here. Similarly, all the cases you may put down and multiply if there is any confusion. Okay, so these particular expressions he has achieved. Now, reducing Einthoven's voltage from Wilson's expressions, which Wilson has got, is the phi LA, phi RA, phi LL's value. So, as per Einthoven, voltages were V1, V2, and V3. And as per Wilson, the voltages are phi LA, phi RA plus phi LL. Okay, that are the gradients that Wilson, voltage gradients, Wilson deducted, which had no direction, but we just simply assume like that this is the phi RA, phi LA, and phi LL. And as per Einthoven, the direction were given of V1 was from right arm to left arm, V2 was from right arm to left leg, and V3 was from left arm to left leg. Okay, see, so these were the directions, but over here, this particular phi RA's value, phi LA, and phi LL, there were no direction has been given by Wilson. Okay, but we just assume that the direction of phi RA will be outward. Okay, phi LA will be outward, and the phi LL is also outward. So all these particular gradients will be working at the outward direction from the center of this sphere or body, whatever. So if we take this particular triangle, which is RA, LA, and center position supposed to be O, origin. Okay, so there is a triangle is becoming, and if we apply vector law of addition, we will get V1 is equal to minus of RA plus LA. Okay, V1 is equal to minus of RA plus phi of RA plus phi of LA. Okay, so if I calculate, see over here as per vector addition rule, this will be becoming phi RA plus V1 should be equal to phi LA. Okay, phi RA plus V1 was equal to phi LA. So this particular expression I have written here as V1 is equal to minus of phi RA plus phi LA. Now I replace the values of phi RA minus of phi RA over here, which was what? Which was phi RA was minus of V by 2 cos alpha plus V by √3 into half sin alpha. Okay, and phi LA was V by 2 cos alpha plus V by √3 into half sin alpha. So these values I have replaced over here and put the expression like that: V by 2 cos alpha plus V by √3 into half sin alpha. This was the value of minus phi RA. Plus phi LA is V by 2 cos alpha minus V by √3 into half sin alpha. So after simplification, the expression becomes V1 is equal to V cos alpha, which was nothing but Einthoven's voltage has been achieved from Wilson's centric dipole model. Similarly, if we calculate V2 from this figure, V2 is over here. So I'll again calculate the V2 from vector summation law, which will be becoming is that phi RA plus V2 is equal to phi LL. Okay. So that should be V2 is equal to minus of phi RA plus phi LL. And after replacing the values of phi RA and phi LL, we got minus of V by root 3 sin alpha plus V by 2 cos alpha minus V by root 3 into half sin alpha. And after simplification, the expression becomes V2 is equal to V by 2 cos alpha minus root 3 by 2 V sin alpha. This is exact value of Einthoven's V2 voltage. Similarly, from the third triangle, that means this triangle, which consists of LA, LL, and origin. Okay, so as per vector addition law, phi LA plus V3 will be equal to phi LL. So that means V3 is equal to minus of phi LA plus phi LL. And after replacing the values of phi LA and phi LL, we got this one. And after simplification, we got the value V3 is equal to minus V by 2 cos alpha minus root 3 by 2 V sin alpha. This is exactly value of the Einthoven's V3 voltage. Okay, so these particular voltages has been deduced by Wilson's centric dipole model. Okay, so now summing all three voltages V1 plus V3, V1 plus V3, if you add V1 plus V3, okay, V1 is V cos alpha minus of V2, V by 2 cos alpha minus root 3 by 2 V sin alpha. Okay, so if you add these two, then you will get the value of V2 is equal to V by 2 cos alpha minus root 3 by 2 V sin alpha. Okay, so this has been achieved. So that means V1 plus V3 is equal to V2. Okay, so this is as per Einthoven's voltage V1 plus V3 is equal to V2. This is Einthoven's law. So from here, the conclusion is that from Wilson's model, we can deduce Einthoven's law. Okay. And as per Einthoven, there were some single dipole inside our body which was acting at an angle alpha. Okay. And as per Wilson, his consideration was also at the center of the body, which is our body is sphere, and at the center there is a single dipole acting. So from both of them, though our present day experimentation reveals that there were some multipoles acting inside our body like that, but both of their laws are going to the same direction. That means their conclusions are same. Okay, so these are the basic fundamental laws of ECG. And again, if you miss any one of these three voltages, that means V1, V2, V3, your ECG will be an unstable one. And why? Nobody knows. Okay, so there are so many experimentations has been going on how Einthoven and Wilson were correct, and why if we miss any one of the voltages or voltage leads which are attached at the left arm, right arm, and left leg, if we miss any one of them, our ECG will be unstable. Experimentations are going on, but still no answers. Okay. So if there is any questions regarding my class and any questions regarding this theory, you may ask me at daseduquestion@gmail.com. Okay. So thank you. Thank you very much. Bye.